Hello everyone. So this is Chomga Sojokin, and I'm going to be taking you through some sections of understanding evaluation or the holistic evaluation of language models. So I'm going to be taking you through some of the preliminaries and some of the tasks that are used in language models. So preliminaries, basically, these are primitives that are required to evaluate a language model. So for every language model, if it's to be evaluated, they are what they call preliminaries. So these are required while evaluating that particular language model. So among these preliminaries, you have three concepts under it. These are the three concepts you're supposed to use while evaluating a language model. So the first is a scenario. Then we have an adaptation and a metric. So I'm going to be taking you through all the three concepts one by one. So let us start with what they call a scenario. So a scenario is basically what you want your model to do. So for any language model, whatever you want it to do is what they call a scenario. And a scenario basically includes three concepts under it. It includes the task, it includes the domain, and the language. So for every scenario, it's supposed to have a task, a domain, and a language. So a scenario, we have already said that it's basically what we want our model to do. And it includes inputting a string into the model and you give it references. So this string you have entered into the model, it's supposed to have a reference so that the model can predict what you have asked it to do, depending on the reference answers you have given to it. So an example of a scenario, I've shown it here below, whereby a model was given a question and the references were also given to it, so that among the references, it can be able to select the right correction or the correct answer to the question that was given to it. So the example below was the scenario that had a question that says, which of the following terms describes the body's ability to maintain its normal state? So after providing a model with this kind of question, you're also supposed to provide it with references. Those are some of the possible answers to the questions you have provided. So some of the references were anabolism, catabolism, tolerance, and homeostasis. So the model was able to predict that among the references you have given to it, it can predict that homeostasis is the correct answer. So basically, this is what we call a scenario. Next, we have what we call adaptation. So adaptation is basically the process of transforming a language model along with training instances into a system that can make predictions on new instances. So a model that is already built on training instances is going to be transformed into a system. So this system will be able to predict the outputs of that particular model basing on the new instances that are going to be provided. So that is basically what they call adaptation. And under adaptation, this is carried out using three concepts. So we have what they call prompting, lightweight fine-tuning, and fine-tuning. So I'm going to explain this one by one. So I'll start with prompting. So prompting is basically just giving a prompt to a model and the model gives you a response. So you give a question to a model and the model gives you a response. That's what they call prompting. So since we are doing adaptation, so we'll be prompting in new instances into the model and the model will be giving us feedback or responses. The next thing is what we call lightweight fine-tuning. So lightweight fine-tuning is basically the making minor adjustments. So you make minor adjustments using the new instances and you feed them into the model. So the model will basically improve its performance due to the minor adjustments you've made. That's what they call lightweight tuning. And fine tuning, this is basically making significant changes. So we make significant adjustments to the model using new data. instead of using the training data that was used to train the model. So the difference between lightweight fine tuning and fine tuning is that for lightweight, they use minor adjustments of new data, while fine tuning, they use significant adjustments. So down here is an example of adaptation whereby we have said that adaptation transforms a model that was being trained or training data into a system that will be able to make predictions of the new data that will be put in place. So this is an example of adaptation whereby on my left-hand side, you can easily see that the model was trained basing on this data, and now they transformed the model into a system to make predictions using the new questions that will be asked to the model. So basically, this is what they call adaptation. So among primitives, we are going to look lastly at what they call metrics. So metrics are used to evaluate the performance of the model. So we execute the resulting system on the evaluation instances for a research, yielding competitions with their log probabilities. So the metrics are basically used to determine how well the model performs. And some of the metrics, I'm going to mention them down there, but they're basically used to define how well does a model work. Is it doing what it's supposed to do? How is it performing? That is an explanation of what metrics are. And under metrics, we have many metrics. That's why this holistic evaluation doesn't only concentrate on accuracy. We go on to concentrate on other metrics such as robustness, fairness, inference runtime, calibration, and other more metrics that were not used to evaluate models by other people, whereby, as it was before, people were only evaluating the accuracy. But now, holistic evaluation means we have to go deep. We're not only supposed to consider accuracy, but we're supposed to consider other more metrics, as I've mentioned. So this is an example scenario. As I said earlier, that a scenario includes three main concepts. So a scenario basically includes task, it includes the domain, and a language. So we're going to look at this one by one. As you have seen in this diagram, they are giving you some of the examples of the task. Then under a domain, there are always three concepts. Those are the what, who, and when. And then finally, the language. So I'm going to go through all these three concepts one by one in order to define what a scenario is. So let's start with uh, what. So basically here we're just talking about how we're going to taxonomize a scenario, or how we're going to evaluate a scenario. And I've already said to you earlier on that the scenario consists of a task, domain, and the language. So these are examples of tasks. So tasks are basically what would you like your model to do? So for example, question answering, that is a task. You can want your model to only, if someone prompts it with some questions, it's supposed to give responses. Then summarization. So that is also another example of a task. Text to command. Then you can have Python to natural language. So there are a lot of what? A lot of tasks that are prompted into a language model, and it basically gives responses depending on that particular task. Then a domain. A domain, mainly we say that this consists of three concepts. That is the what, when, and who. So the what involves the type of text which captures the subject and the register differences. So what do I mean here is that when you're inputting a prompt into a model, what type of text have you used? So some of the examples of the word concepts are like the Wikipedia. For example, you have input a text from the Wikipedia, then social media, news, specific papers, or fiction. So these are some of the types of text that are expected by the model. Then we have the when. When is like the time period. So when was the text created? So basically, when you're prompting, when was your text created? So that is used to know that the period of time your text falls into, so that the model can make complete responses or adjustments depending on that period of time. Then who? Who means the demographic group? Who generated the data? Who is or who the data is about? So the data you are prompting into the model, we're supposed to know basically who are those people that generated that particular data. Then what is the data? Who are those people that the data is talking about? Are they black, whites, men, women, children, elderly, youth? So any group falls under the category of the who. So basically, this is what a domain is. Then lastly, we are going to be talking at the language to complete the concept of scenarios, whereby we say that each scenario has to have a task, a domain, and a language. So for the language, it's basically in which language do you want your model to perform. So the language can be maybe English, Spanish, maybe French. So any language can be part of what can be used to train the model, and the model always gives prediction basing on that particular language. So we are done with scenarios. Now I'm going to be taking you through the sum of the tasks. So some of the tasks, what I'm talking about, as I said earlier on, these are some of the tasks. So I'm going to go through some of them and see what each task is, its problem setting, and the data sets that are used in order to come up with a model which can provide such a task to the user. So let us start with question answering. So question answering is basically you're prompting a model with a question, and the model is supposed to give feedback. So that is what they call question answering. So it basically consists of three concepts. That is language understanding, interpretation, knowledge, reason. So for every model to perform the task of question answering, it basically bases on language understanding. How deep does it understand the language you have used to write that question? Then integration of knowledge. So basically the model is supposed to be containing that knowledge that is going to answer that particular question. Then reasoning. So depending on the question you have asked, the model is supposed to reason well enough in order to provide a convenient answer to that particular question. So that is what they call question answering. So its problem setting is down here, and we are trying to show that a model in question answering, given a question, the task of the model is to predict the correct answer. So the example of a question that was given here is like, where was the painter of Mona Lisa born? So the model is basically supposed to know that the correct answer to this question is that this guy was born in Italy. So that is basically the format or the concept or the problem setting of the task of question answering. And some of the data sets that I used, I've given them below. So I have data set, I have natural questions, narrative question answering, Hella Swag, and open book question answering. So basically, each of these data sets has a year on which it was created. So those are the years that I've included in the brackets. And on my right, you can easily see an example of question answering. So it is a scenario that consists of a task, which task is question answering, whereby they prompt a model with a question, and this model is supposed to give feedback or response to this question, depending, remember that, depending on the references. So for every question, there are supposed to be some references to that question, so that the model can pick among all the references given to it. It can easily pick the correct among the references given to it. So next, we have next the task we are going to see is the information retrieval. So this focuses on the passage ranking, where a given query and a compass C So for information retrieval is basically when a user prompts the model to return some information to the user. So basically this uses a data set that has a large corpus. So a large corpus, I mean that this data set is going to be having a lot of passages. So we consider only ranking top k passages among the set of passages retrieved for that query queue. So basically here, you prompt a model to give you some information, and this model has a lot of passages. So it will rank these passages so that these passages are ranked in such a way that they include or they in series of how well are these passages while answering, or how do these passages come up while answering the particular prompt you fed into the model. So down here, you can see that there is some input, which was how much does a speculum bear weigh. So among all the passages in the model, they're supposed to rank them depending on the particular question. And these passages, one of them is supposed to be having the answer to the particular question that was asked by the user. So the problem setting is that a passage CI and a query Q, we ask the model whether the passage contains an answer to the query. So what basically we do is that if we feed a prompt into the model, so we have to check each and every passage in our compass. So for every passage, we ask the model whether this particular passage includes the answer to the particular prompt that was fed into the model. So if the model answers that yes, that implies that this passage is supposed to be ranked depending on how how good is it to answer that particular question. So if the model answers yes with a high probability, then we rank the corresponding passage higher. So we rank it higher more than those other passages in a particular what? In a particular focus. While if the model says no, the higher no answer with the higher probability, that achieves the opposite. What do I mean here? But that if a model is asked whether a particular passage possesses the answer to the question, and the model really thinks that it doesn't possess the answer, so they will basically rank this down below all the other passages that consisted the answer. So some of the data sets that are used here, we have MS Marco routing dataset, and we have TREC 2019 Deep Learning Network. So these are some of the datasets that are used while carrying out the task of information retrieval. So next we have summarization. Summarization is also another example of a task. So summarization is basically the model is fed with a particular document, and the model is requested to give a summarized reference of that particular document. So here basically we focus on removing less critical information from the document that was provided. So we remove less critical information and we remain with only information that is relevant, so that the model summarizes the document but consisting the relevant information. And we do this to avoid redundancy. So down here, there is this example. Down here, we have an example of summarization whereby the model was fed with a particular document or a passage, and it was capable of summarizing it so that doesn't it includes the relevant information as it is in the original document, but removing the irrelevant or the less critical information in order to avoid redundancy. So the problem setting here is that to evaluate the model performance, the model-generated summarization is compared against a human-authored reference summary using automated metrics for overall quality, and the following are some of the metrics that are used. So we use the first metric while carrying out summarization is faithfulness. So faithfulness basically refers to whether all the information in the model or whether all the information, the model summary is supported by the article. So every information that was included in the model, it was supposed to be supported by the what? By the article that was fed into the models. So for every information that will be generated for a particular prompt, for example, you're telling a model to summarize, the output should be checked very well to see whether it supports the information that was given, the particular document. Then exactiveness. So exactiveness refers to the extent to which model summaries involving copying from the input document. So we want the extent to which these summaries involve only copying from the original document, but not finding the relevant and the less critical information, and you remove it from the particular document so that you stay with the relevant information. So the data sets that are used, they include CNN Daily Mail and XSUM. So these are some of the datasets that are used during the task of summarization. So next, we are going to look at what they call sentiment analysis. So sentiment analysis refers to the emotion or attitude behind a particular piece of text. So sentiment analysis works different from other tasks as we have been seeing, in such a way that for it, they give it a particular text, and it's supposed to detect whether what emotion or what attitude is behind this text. So it's not just supposed to either summarize or give an answer. It is supposed to just tell us the attitude or the emotions that are behind this piece of text. So the data sets used include IMDb, and its problem setting is basically that this model, if you provide it with a sentence, if a task of sentiment analysis is going to be used, this model is supposed to either predict positive or negative. This implies that if you provide model with some particular information and the tone or the task or the attitude behind this task is rude, so that implies that the model will say negative, will give an output of negative. If it's not, the model will give an output positive. So this sentiment analysis only has binary answers. So it only has positive or negative. That's the problem setting of sentiment analysis. And down here is an example of sentiment analysis, whereby the model was provided with a particular text, and it was supposed to either conclude positive or negative in order to know the attitude or the emotion that is behind this particular text. So last but not least, we're going to look at what they call consistent detection. So this is a task of identifying when input data contains toxic content, which originates into it for content moderation on the internet. So this is basically you're trying to know whether a model can produce toxic content, because this is content that is harmful to our environment. So for every model, if it is to produce a particular information from it, that content should be identified, and researchers should conclude that it's not toxic depending on this toxicity detection. So basically, that is what toxicity detection is all about. Then the problem set. So this is the same as sentiment analysis. When a model is given a text, its job is to just predict either true or false. So it has nothing to do whether spitting a lot of words onto the board. No, no, no. Basically, it's supposed to just tell us whether it is toxic or not. As you are seeing down here, that the model was given an input and it was given references which were binary. That what do I mean by binary? They're supposed to be true, which is either true or false. So this model was given a particular input, which was raised well, please show me where the kettle of education has been gutted. Simply preposterous. So the model is just supposed to predict whether this statement is toxic or not. And given the references of Manuel Vitor, can be easily true. check and see that it is what? It is true this statement is toxic. So the last will be malicious text classification. Basically, this refers to the task in NLP where a model takes input and assigns it a label. So the basics under malicious miscellaneous text classification is that you just provide the model with a question. And this model is supposed to categorize this text or this question into 4 different groups, which can be language identification, sentiment analysis, toxic classification, and toxic detection. So basically, this is why I call malicious text classification. So that's all for me, guys. We meet next time. Thanks for your time.